Good evening and welcome to Communicating Science Effectively in Today's World. My name is Miguel Garcia Garibay. I am the Dean of Physical Sciences, which is proud to co-present tonight's event alongside UCLA's Department of Earth, Planetary, and Space Sciences. The other departments in the Division of Physical Sciences at UCLA are Atmospheric and Oceanic Sciences, Chemistry and Biochemistry, Mathematics, Physics and Astronomy, and Statistics. As we celebrate the centennial, we invite you to find out more about our scientists, how they have helped light the way to a quality of life that, if you think about it, was unimaginable 100 years ago. These last 100 years have just been exceptional, probably the period of change in humanity that is most remarkable, and much of that clearly thanks to developments in science. The motto of UCLA Physical Sciences is, what if? Questioning, what if this could happen? What's there? What's beyond? What could be? And our faculty and students are trying to really find questions to the deepest, answers to the deepest questions that happen in the universe. Our work reflects the spirit of exploration and problem solving every day. Among other things, UCLA Physical Sciences researchers have developed life-saving drugs that treat prostate cancer. They have observed the farthest start ever seen. They are using statistics to illuminate the human genome for biomedical research. UCLA Physical Scientists have also enhanced the magic of movies, the movies we love, through innovative mathematical algorithms. And we are very proud to provide a critical understanding of climate change. The profound impact that had by UCLA Physical Sciences faculty upon the world has resulted in 6 Nobel Prizes. 3 physical sciences alumni have also been Nobel laureates. The new discoveries and solutions that our scientists develop must reach people in the community in order to make the world a better place. And this is where accurate science communication is key, and why strong science communicators are so important. We are very grateful to have such a group of allies joining us for our discussion today. And we are particularly grateful to the Luskin Endowment for Thought Leadership for making today's event possible. I would like now to invite tonight's moderators and one of the division's great teachers and scientists to the stage. Please welcome Jean-Luc Margot.
Good evening, everyone, and welcome to UCLA. In the last 100 years, science has increased our life expectancy by an astounding 40 years. Aren't you glad to be here today? Science saves lives all the time. It improves healthcare, car safety, building safety. It improves a way of monitoring and mitigating natural hazards. Science enables the comfort of modern daily life. It allows us to call loved ones across the world. It makes air travel possible. It is a tremendous engine of economic activity. Science also provides a way of understanding the world and guiding important policy choices about societal concerns, including public health and public safety. Science can guide us when it comes to making smart decisions about climate change, vaccines, fracking, and many other issues. Science is everywhere around us. Now, about 1 in 10 American adults have a degree in science or engineering. So if we want people to benefit from science and make informed policy decisions, then it's critical that scientists be able to communicate their results with the entire population. So I'm thrilled to welcome you to this event today and panel discussion that is brought to you by the Department of Earth, Planetary, and Space Sciences, and that is enabled by the Meyer and Renee Luskin Endowment for Thought Leadership. To address these issues today, we're very fortunate to have an esteemed panel of experts, and I'm thrilled to now introduce our panelists. First, we have Lawrence Bender. If you could please come to the stage. His film, An Inconvenient Truth, raised significant awareness about climate change and won the Academy Award for Best Documentary Feature. Next, we have Nadia Drake, who's a science journalist for National Geographic, who also writes for the New York Times, The Atlantic, and other publications. Next, we have Jacob Margolis, who is he's a science reporter for KPCC 89.3 Southern California Public Radio, and he's the host of the podcast, The Big One, Your Survival Guide. Next, we have Deborah Nedburn. She's a science reporter for the Los Angeles Times. And finally, David Salzberg. David's a UCLA professor of physics and astronomy, and he's been the science consultant for the TV show The Big Bang Theory since its inception. So let's get started. I'll take a seat and start with the first goal of science communication, which is really to improve people's lives and influence beliefs and policy, opinions, behaviors. And I want to start with Jacob. Your podcast, The Big One, Your Survival Guide, describes the moving story of Sarah McBride, who is a public communication officer in New Zealand. And her job is to inform the public about the earthquake hazard. And she pours her heart and soul into the job, and she witnesses then the 2011 Christchurch earthquake, magnitude 6.2 earthquake. 185 people are killed. And Sarah realized that to some extent, her communication efforts had not been entirely successful. So let's listen to a short excerpt from the podcast.
Christchurch had a profound impact on me. But I knew I wanted to help.
That's a lot to shoulder.
Yeah, it is. And so Sarah decided she was going to get a PhD in communication.
Why communication?
Well, because it was a communication problem, right? She had told people the earthquake was coming, that this was a seismically active region. She told them it was going to be bad. She told people to prepare. But they weren't listening, like they didn't get it.
So Jacob, I wanted to ask if Sarah's story influenced the way you designed the podcast.
Yeah, absolutely. So I don't know if you guys know, but a big 7.8 San Andreas quake could hit at like any second. It sounds like, a lot of you probably know this, but a lot of our audience that we went out and we actually talked to in the street didn't connect with that at all and didn't realize that. And I grew up in Los Angeles, and from childhood, they had elementary school through middle school, high school, they had hammered into us that big earthquakes were coming, big earthquakes are coming. And what we saw was just a gigantic disconnect between what people understood, okay, we're going to get into the desks, there might be a little shaking, and then we can kind of move on, and people actually processing, oh, hey, 1,800 people dead, 1,600 conflagrations, giant fires breaking out, hospitals overrun, just tons of resource issues. And when we talked to Sarah, she saw the exact same thing. Before Christchurch quake happened, which was a really, really bad earthquake back in 2011, she had been trying to communicate to people hey, this thing is coming, this thing is coming. And for ages, she had been putting out pamphlets and information, kind of wonky information of well, technically this could hit in this spot, and this could possibly lead to X, Y, and Z, or really X to Z deaths, a lot of different variables, all this kind of stuff. And what she found was that it didn't connect with anyone. And after the earthquake, people were like, why didn't you tell us this was coming? But she had. And that was a major revelation for her, as you kind of started to hear in that clip. And it was a big influence for us, because we realized, we had really good material for this podcast that we put out about the big San Andreas quake. We had U.S. Geological Survey peer-reviewed science, and like it was really good. I could just read it back to you. It's like 300 plus pages of this one report that's so fascinating, but most people don't really care that much. And what Sarah helped us realize, and what we really tried to institute throughout the entirety of the podcast, was we needed to make people care through narratives, through personal storytelling, we needed to make sure that people could really imagine themselves in this thing. And if you listen to the first episode of the podcast, we start off with a narrative that we invented based on the science. We put you in downtown Los Angeles. And that was very much on purpose, because we needed you to be shocked, hopefully imagine that you could be going into work that one day, or separated from your family and isolated once this big quake hit. So yeah, Sarah definitely, she showed us sort of what to do in terms of needing to connect with people using all that stuff, and that's what we tried to do.
Thank you. So Lawrence, your documentary, An Inconvenient Truth, raised absolutely unprecedented awareness about climate change. And you used compelling graphics and animations to convey the evidence and the dangers of climate change. I want to show a 1-minute segment.
If Greenland broke up and melted, or if half of Greenland and half of West Antarctica broke up and melted, this is what would happen to the sea level in Florida. This is what would happen to San Francisco Bay. A lot of people live in these areas. The Netherlands, one of the low countries, absolutely devastating. The area around Beijing, that's home to tens of millions of people. Even worse, in the area around Shanghai, there are 40 million people. Worse still, Calcutta, and to the east, Bangladesh, the area covered includes 60 million people. Think of the impact of a couple 100,000 refugees when they're displaced by an environmental event. And then imagine the impact of 100 million or more.
So Lawrence, can you tell us about your motivation for producing this film?
First, thanks for having us here. And it's probably one of the biggest issues facing us today, I think. And what motivated me, I guess, was I saw Al Gore do a slideshow. And I think everybody in the room was a room like this, and Al was up there doing his slideshow. And I said to myself, wow, what can I do? And I had this crazy idea that it needs to be a movie. So, if you could imagine going around pitching people, I want to do a slideshow about Al Gore. Now, of course, he had lost the election, and he had a slideshow, and I want to make a movie about him. Could you give me $1 million? And who would do that? But Jeff Skull did it instantly, and he's like, he's an extraordinary man. He created Participant Media. But what's interesting about, what you see here is some scientific. And by the way, it's funny, I screened the Inconvenient Truth, the first one, I forgot what year, but it was when President Bush was president, and I went to DC and I screened it for the science staffers, the congressional science staffers for the Republicans. And I asked them, so we sat in a very small room, there's 6 of them, and I asked them, is there anything in this movie that you can refute in terms of scientific evidence? Because when we went to make the movie, we went to approach Al, we were really scared that Al would say no, and we came up with a whole plan, who's going to say what, and I had never met Al Gore before. And so, of course, he said yes, but his one thing was the science has to be accurate. And we said, of course. So the science staffers, this is what reminds me of this, is the science staffers said there's nothing in the movie that has bad science. All the science is correct. They said the only thing in the movie is that you says when Greenland melts, such and such is going to happen. And we said, I said, if you had to go back, because we said if Greenland melts. So we weren't predicting it was going to. Now, the problem is, years later, that Greenland is in much worse shape than it was when we made the movie. But there's a lot I could talk about. Right. But the motivation was simply seeing Al Gore do a slideshow. I'll say one other thing. One of the most important things in making that movie was science is boring to most people. Now, personally to me, it's not boring, but to most people, you start getting into facts about somebody, just not going to be interested. And making it, if we would have simply filmed a video of his slideshow, it'd maybe fine to send out his DVDs to science classes in high schools, and maybe they would have watched it and would have had to suffer through it. But what we did, of course, is we came up with an emotional angle, which is to intercut Al Gore's journey. And it talks about him when he was a kid. His father grew, it was a tobacco plantation. A member of his family ended up dying from that and so forth. He lost the election. There was a great dramatic thread of the character of Al Gore intercut with the slideshow. And that's what made the movie work. It wasn't just the science. It was the science combined with this fallen hero who was coming back to do something he was passionate about. And that's what we're here to talk about, really, is how do you communicate science? And I know we'll talk more about this, but finding ways to communicate science is very difficult. And that's what we ended up doing successfully in the movie.
Thank you. So a perfect segue into our next topic. How do we make science exciting to the public, right? That's another goal of communicating science. And Deborah, you wrote a fascinating piece in the LA Times about how ancient eclipse records written on clay tablets buried in the sands of Iraq from 2,500 years ago allow scientists to detect and measure changes in the Earth's rotation and how the length of day changes as a function of time, right? That's a fascinating story. So have readers reached out to you about this story or the story that inspired them?
Yeah, I think I may have heard from more readers on that particular story than any other story. It was just so cool. These scientists had spent 40 years like unearthing all these ancient astrological records and then kind of compared what was written in those tablets to computer models today. And I personally just love the idea that ancient astronomers are informing science that's happening today. It's like this, long line of science. But okay. I also wanted to talk about another really exciting thing that's happened in science recently that I think everyone across the planet is so excited about, which was that first image of the black hole. I hope you guys saw it. It just felt so thrilling to me, everything about it. It was this supermassive black hole in this distant galaxy. It took a telescope, a virtual telescope the size of the Earth to image it. And I really felt like readers were, just got it, just got how thrilling the whole thing was. And I'm not sure it's of consequence exactly, but it's amazing. And those are the types of stories I'm personally really drawn to.
Thank you. And Nadia, you won a Science Journalism Award for your story for National Geographic, where you raced with a team of scientists in an airplane to catch the shadow that Pluto was casting from the light from a distant star, and then in this flying telescope measure the shadow. I mean, have you gotten reader feedback about this story?
Yeah, so one of the things that I am very fortunate to be able to do in my job is to actually report from in the field. So I can go out to where scientists are doing the work, where they're asking the questions, where they're running into trouble. And so I travel a lot to places like Peruvian Amazon, and in this case, a flying telescope, which sounds really bizarre, and it kind of is. It's like they literally took a 747, scraped out the insides of it, stuck an infrared telescope in the back with a big door that opens. So basically, like, a quarter of the plane opens up while this thing is in flight, and it flies really high, like above 40,000 feet. And the whole purpose is to do astronomy from above the clouds, so you can always see what's in the sky. And so what happened during the story was, it was a couple of weeks before the New Horizons spacecraft was going to fly by Pluto. Are you guys familiar with that? So, good, okay. One sentence summary: in 2015, we got our first really good look at Pluto. And a couple of weeks before that was happening, Pluto was passing across the face of a distant star, which sounds really boring, and it kind of is, except that when Pluto passes across the face of that star, we can actually see its shadow on Earth for just a little bit of time, and it's a narrow shadow. It's only as wide as Pluto itself. And based on that, you can come up with all kinds of information about what this world is like. What is its atmosphere like? Are there rings? Are there hazards that the spacecraft flying by in a couple of weeks might run into? And so for scientists, it was kind of crucial to get this observation. And what they did was they were able to plot the track that that shadow would take across the Earth, which to me is just mind-boggling. I don't know how you do that, because everything is rotating and things are going really quickly. And they realized the shadow was going to pass through the southern Pacific. So a bunch of teams fanned out across New Zealand and some other places on the ground, but of course when you're on the ground, you just kind of have to pick your spot and hope it's not cloudy. And so you have like, you know, a minute to watch this thing happen. And I decided to go up in this flying telescope with these scientists who were going to try to actually intercept the shadow as it's moving across the face of the Earth, open the telescope at the right time to just get this tiny observation. And all they're going to do is just see a brief dip in that starlight as Pluto passes across the face of the star. And to me, that's the kind of story that I think illustrates a very human side of science. Like, as we've been saying, science is everywhere, but it's a fundamentally human enterprise. And I think one of the problems is that people think about science as this kind of monolithic black box that tells us things. And it's this thing that asks questions and data comes out. But it's people who are doing this. And a lot of it is just science that's driven by curiosity. Like, what is Pluto like? You know, so people love that story just because it's kind of, it's weird. Like, you're flying in a telescope and you're gonna look at Pluto for that long and come up with some really cool observations.
Thank you.
It did work. Yeah, and so it's the kind of observation that doesn't always work.
Right.
And so the scientists who do these things, they have all these trinkets that they bring up with them. Like there's a bone that some guy brought back from a previous successful, they call these things occupations, that now they have to carry the bone on every trip that they go on, and just kind of funny things like that that really lend a personality to the experiments themselves.
Thank you. So David, you communicate science to other scientists. You write articles, you go to conferences, right? But do you think it's important to communicate science to the general public, and if so, why?
Well, first of all, doing science is really expensive. And so I wouldn't want to have to fund it myself. Our taxpayers, 350 million some odd US taxpayers worldwide, billions of people, are funding these things that we get to do. This imaging of the black hole in Andromeda, or the Sophia telescope that we just heard about, with the chase the shadow. These are all part of very expensive scientific programs. So we owe it to the people that are paying for it to let them know what came out of it. And if we're ever going to go back and ask again, in our own enlightened self-interest, it makes sense to do that. But also, in addition to this kind of somewhat transactional approach that I just took, it's really wonderful to contribute to the intellectual discussion that we have as a country and as a world. We talk about art, we talk about music, we talk about literature, and science is part of that global conversation that we have. And we've heard about how poetic it can be. And so it's really great to be part of the world discussion.
Thank you. So you mentioned about the costs. I'll try to quantify it a little bit. The entire NASA budget, which funds not only the Sophia telescope, but all kinds of spacecraft exploration of the solar system, human exploration, aeronautics, and so on and so forth. That's about half a cent on your tax dollar. So yes, it is expensive, but relative to other items in the budget, it actually isn't. Right? Great. So Next, I'd like to talk about the fundamental difficulty of communicating science, even for non-controversial topics. So there are at least two factors that contribute to this, right? There's the complex nature of scientific information, and there's also the ways in which people process new information. So let's start with the complex nature of scientific information. That often involves talking about numerical concepts, probabilities, uncertainties, data. So Deborah, can you share some examples of complex scientific information that you described in your work and how you dealt with this challenge?
Yes, I'm like furiously looking through my notes because when it's complex, I would like to have some notes, but I'll do my best. Yeah, so I recently wrote about the new SI definitions. Do you guys know what that is? They redefined the kilogram and the mole, the ampere, the Kelvin. And I thought it was like it's just a cool story to think about the fundamental science that underlies stuff we take for granted, like measurements. But the new definitions rely on constants, like that are built into nature. So like Planck's constant, the Boltzmann constant, Avogadro's number, and that's getting kind of complicated for my readers who I do not assume have PhDs. But I really couldn't tell the story without at least mentioning these constants. So I did a lot of reporting really to try to figure out what I could leave out of the stories so it would still be correct and make sense, but I just didn't want my readers to get frustrated and be like, I don't know what you're talking about, and turn away. So the way I approached it was thinking about stuff that we all kind of know, like we know the speed of light is the same across the universe. So that's like a constant. So maybe you don't really know what Max Planck's or Planck's constant is, but you kind of understand that the speed of light is a constant. So I was able to equate those. I was thinking about pi and how we know how pi relates the circumference of a circle with its diameter. And similarly, like Planck's constant relates frequency and energy of light. Is that correct?
Yes,
is there anyone here who knows? Yeah, right? That's why I needed these notes. But that's about as deep as I got. And I didn't want to get too much into the nitty-gritty. I really, but I felt that readers would now kind of be able to understand what was going on with these changes. So, but that's challenging. Yeah.
I'm curious how the different journalists decide to what you decide to include and what you decide not to include, because I too do hours of interviews about things, and then I have 7 minutes to talk about it on the radio and explain it to an audience that's half listening while they're driving their kids to school or whatever like that, which I totally appreciate because that's stuff that I do too. But it's something that I definitely struggle with a lot, and something that we end up paring down a lot along the way. And there's also this self-consciousness that also goes on with science reporting a lot of the time. Since I'm not a scientist, I don't have a PhD, but I want to make sure that, one, I'm honoring all the work that the scientists did, but also conveying enough information for the audience to feel like, hey, I might be able to talk about this at a party for 3 minutes later tonight. That's like a very specific goal I have.
Yes.
Like, how do you guys, all of you, decide to do that?
Well, I'll tell you that my guiding principle and again, I always like to say too that, science reporters they write for different audiences, and my audience, I consider someone maybe with high school science, that's kind of who I'm envisioning that I'm writing for. And my goal is that the reader says, wow, cool, and the scientist says, yeah, that's not wrong. I better think success.
So again, perfect segue. David, you were hired as the science consultant for the Big Bang Theory, very popular sitcom. Do you think it's important that science concepts be portrayed accurately in a fictional TV show?
That's right. So I spent 12 years dreading getting something wrong and something slipping through. So it's important to note it's a creative decision about whether or not the science should be accurate on a TV show or not. And an example one could think of, imagine the movie Back to the Future, where Marty McFly is going to go back and save his parents' marriage so that he can be born. And he goes to Doc, and Doc says, "No, you can't travel back in time." Well, that would be a nice scientifically accurate movie that would be really dull. So the writers in The Big Bang Theory were trying, if I can speak for them, were trying to create a world that felt like our own, felt real. The characters felt like people you might know. You just hadn't met them yet. And so by bringing in the science being correct, first of all, it didn't break the spell of watching the show. A lot of fiction that I've learned from hanging around with the writers is a lot about doing something believable and getting people to suspend their disbelief because they're really just watching a screen. And all these little things, keeping things accurate, helped sell the idea that you get lost in the show. And it was amazing. You think about, of course, the writers and actors on a show, but there must have been about 20 different departments. There's sound, and there's cameras, and there's wardrobe, and there's set dressing, and everyone there really wanted to make such a great product that they would call me, what color should the laser glasses be? Everyone really believed in the work they were doing and really wanted to get it correct. That said, one of the co-creators, Bill Prady, who obviously created the show, explained my job to me. Now, maybe a lot of people remember an earlier sitcom called I Love Lucy with the husband, Ricky Ricardo. He said, "You don't need to know Spanish to know when Ricky Ricardo is angry." And that's the science on this show.
Thank you. So we talked about beliefs, and that's another challenge to communicating science, because all of us have a mental model of the world, and we have cognitive biases that affect how we process new information. So we use mental shortcuts. One of them is called motivated reasoning, which is a tendency for us to, when we receive new information, to verify whether it's aligned with our pre-existing beliefs and accept it if it's aligned and tend to reject it if it isn't, right? So we're naturally reluctant to accept facts or evidence that contradict what we already believe. So Jacob, can you describe an instance where you had to tackle this problem of pre-existing or questionable beliefs in your work?
Yeah, I mentioned a little bit of it earlier, is that people don't believe an earthquake is going to happen. Like, we had people on our staff that talked to their roommates. They actually went out to the park and talked to people in the park and said, "Oh, do you think an earthquake is coming?" They'd be like, "Nah, it's not going to happen." And it's like, it's one of those things that there's no both sides to an earthquake happening. Now, you might not have the level of intensity that we're projecting, but it could be somewhere. It's not going to be good. And so we ended up, that was something that we had in our minds an awful lot as we were preparing our product, was like, how do we combat that? And the way that we did that was just unimpeachable presentation of the well-done science and the narratives to convince people that their lives could actually be impacted. So how do you both sides earthquakes? I thought about that a lot, and it's surprising.
Thank you.
Yeah.
So we've mentioned already the use of narrative in communicating science, and this allows reporters and journalists to convey complicated scientific information in the form of a story that explain complex issues. And this can actually increase audience engagement. There's stories about this. It can be easier to remember and process than traditional forms of scientific communication. So Jacob, I'd like to show another segment of the Big One podcast. And as a fair warning, this is also going to serve as a public service announcement, because after all, we're Earth, Planetary, and Space Sciences, and we want to make sure you go home with some good, solid scientific advice. So let's listen to that.
If you're more prepared, you're going to suffer less. That's really what it is. If you have food, if you have water, if you have your emergency supplies, you're going to limit the amount of unnecessary suffering that you have to face during those early days of response.
This is why we have a story. A narrative where we speak directly to you and walk you through what it could be like for you when this big earthquake hits. It's why we included not just the science, but the stories of the scientists who have informed what we know about a major quake hitting here.
So I was going to ask you if you could elaborate on your use of narratives in the podcast.
Yeah, like I said earlier with the Sarah McBride stuff, it gives people something to kind of hold on to and relate back to their own lives. I haven't listened to this podcast in so long. Just listening back to that, it immediately got me thinking about episode 3. And so episode 3, in theory, it gets me really excited because it is 100% about the science of plate tectonics. Halfway through that sentence, you guys fell asleep. And that's what we recognized about our audience. And so that was going to happen with our audience too. So what we ended up doing was we went on a deep dive to look at the different people that had some of the biggest influence on our understanding of how the Earth moves, why plate tectonics exists the way they do. And one of the most satisfying things in journalism is when you come across a crazy story. So there's this guy, his name's Alfred Wegener. If any of you have listened to the podcast, sorry for repeating the story. But he was a scientist back in the early 1900s who, it's a long story, but basically comes up with the theory of plate tectonics, more or less. And it turns out this guy's like a polar explorer. And so in between writing these like controversial papers about this idea of like the continents that could possibly fit together, he like is out on polar expeditions for years. A polar bear attacks him. He shoots it in the face right in the nick of time and ends up dying on an expedition before his theories are kind of accepted. And they weren't completely right, but they were on the right track. And we used stories like that to tell, like, okay, so we could talk about how plate tectonics works, or we can kind of tell you the story of this guy that's sort of figuring it out. But really, the polar bear story is kind of like the coolest part, and the shooting them, you know. And we went from there. We go through we really had for every single scientist we talked to, or every sort of scenario that we gave. Like for instance, a building collapse. You can say a building is going to collapse. People, okay, I can vaguely imagine that in my head. What we did to really drive that point on home is we had our kind of fictional narrative that we invented. So you, the listener, in downtown LA, and we scored a building collapse. We had a composer for the podcast. And then we also interviewed someone who was in a bus in Christchurch when a building collapsed. And she was the only person that survived in the bus. The front of a building fell off. And she describes in very, very intense detail what it was like to be in that bus as it was slowly being crushed by a wall of bricks, and about being pulled from that bus and her subsequent recovery. And as you can see, as I tell that story, which is truly a heart-wrenching story, now you can imagine what it might be like to be stuck in a collapsed building. And now you might actually go and, I don't know, maybe you'll go buy some water or some extra food for the earthquake. And so those stories really helped us get that across to the audience. And like I said, for every single point that we made, we tried to have one. And the episodes that we were really struggling to write, we realized, oh, we don't have a core story. And so they were indispensable. I could go on, there's a million of them. I'll stop. But they're really, you should listen to the podcast. I mean, you should listen to it. If you live in Southern California, it's worth a listen, at least the first couple of episodes, because you'll get an idea of what it's going to be like when it does hit.
Agreed.
Yeah.
So Lawrence, you mentioned earlier interweaving the story of Al Gore in the documentary. So let's watch an edited segment of that.
April 3rd, 1989. My son pulled loose from my hand and chased his friend across the street. He was 6 years old. The machine was breathing for him. We were possibly going to lose him. He finally took a breath. He was so brave. He was such a brave guy. Just turned my whole world upside down and then shook it until everything fell out. My way of being in the world, it just changed everything for me. how should I spend my time on this earth?
Right, so you've mentioned this before, but I wanted to ask, can you elaborate on your reasons for including this personal story, very personal story, in a documentary about a scientific issue?
Yeah, it's as everyone's been talking about, storytelling. It's just all about storytelling, and we just felt just explaining the facts, as we just heard, it's much more interesting to hear about a woman who almost got crushed and seeing all the people dead around her. It's just, that's interesting. That's relatable in some kind of way. You're listening to a personal story, and in this case, it's the same thing. You're listening to Al Gore talk about very, very personal things that are all touching to us. But you have to do this no matter what we're talking about. It has to be, there has to be some kind of element that makes you go, oh, wow. So I could just tell you another story. Years ago, after the Gulf War, before the invasion, no, when it was after the Gulf War, before 9/11, I'm trying to remember when it was exactly. It's been a while. But we were, Arianna Huffington, myself, Scott Burns, we wanted to do an ad about how America's being, so it was how America's addicted to, well, I'm trying to remember when we did this. But anyway, it was a long time ago. And we wanted to do something controversial because if you just put out something just kind of explaining it, no one's going to really listen. You have to rise above. That's the other thing about talking about storytelling or making a difference or trying to communicate. There's so much, what we're not talking about is that there's so much noise. There's so much going on in the world about so many different issues that how do you rise above that buzz, that hum? And now, of course, there's so much fake news and bad facts and what's real and what's not real. And it's just impossible to rise above that, right? So back then, there was no fake news, as far as we know back then. But there's still a lot going on in the world. And so we wanted, what I've found is the best thing to do is to come up with something that's very controversial, that's going to go viral, that's going to make people go, what? So what we did was, at that point, Arianna Huffington had a column in the LA Times before the Huffington Post, and she wrote a column that we were going to talk about this, and she asked people to donate, and that's how we raised the money to do this spot. And basically the spot was this. We did that because we couldn't get people to, the bigger organizations give us the money because the spot was too controversial for them. So they want us to water it down. Now we decided we didn't want to take their money and water down the spot. So the spot was simply, of course, it was after 9/11, now that I'm thinking about the spot was. So most of the terrorists that flew over and blew up the buildings were from Saudi Arabia. So we just simply had a guy, Fred, filling up his SUV, because at that time, having an SUV was a symbol of being an American. You have an SUV, you're an American. And so what we did was, here's Fred filling up his SUV, and he's supporting the terrorists. Because every drop of gas that you're putting into that SUV of his is coming from over there, and that's giving them the money to blow up our buildings. It was a very simple spot. But, and then we had enough money to put on a few places, different locations around the country. And immediately, we got banned on certain networks. And then Fox News, Americans for, we called ourselves something, Americans for some kind of change, have made this ad, and they played the ad. And then, of course, they had myself, Arianna, and other people on to debate. But all of a sudden, we had millions and millions of dollars of free advertising because every major news network was playing the ads that were banned on other networks. So I found myself, now I'm not a politician and I'm not an expert, but I found myself debating real experts who were debating me on this issue. And it was terrifying. I'll give you one example. Arianna was always being booked. I said, Lawrence, she calls me up. I'm supposed to be on, what was it? I think it was it was CNN. Supposed to be on CNN. I can't do it. Can you do it for me? I go, what's it about? She says, well, it's Grover Nyquist. I'm like, I can't debate Grover Nyquist. He's like an expert on taxes. And we're talking about how they just changed this law to give people buying lightweight trucks tax breaks so they could buy more lightweight trucks and spend more money on gas. So I can't do that, Ariana. She said, no, I'll coach you. So I get in the car, I'm driving over, she's telling me what to say. I go through the metal detector, I'm on the phone, they're putting me up, and then I said, okay, we're on there. I hang up the phone to Ariana, and there I am debating him. And it was like a prize fight. The good news was that there was a group of people in the audience that were talking, they were asking questions. It was him and me, and I gave him everything I got, and then I knew if he came back to me, that was it. I had nothing left to say. But that's all the time we have. Lawrence gets to get the last word. But anyway, this all came from this spot that we made that everyone wanted to water down. And so for those on the panel, for those in the audience, are, getting above the buzz, the hum of every people just trying to get their kids to school and have health care and so forth. It's really hard. So I like to be controversial, to get the news across. Have the science right, but be controversial.
So I wanted to mention, when I watched that segment of An Inconvenient Truth, it made Al Gore much more relatable to me.
Yeah.
And you spoke about the possibility of losing something precious. And then you made the connection in the documentary about the possibility of us losing our planet and our way of life. So I thought that was very...
Yeah, you're absolutely right. I digressed. that was the point, and is to become relatable, have a figure become very relatable. Yeah.
So Nadia, you've also used the narrative to convey science results. So you wrote a piece where you write a letter to a spacecraft, and this letter is very personal, and it makes you and the science more approachable. Have you used this many times, or have you used other techniques? What do you use to write your work?
So the letter to the spacecraft is part of a year-long series that National Geographic is doing, because we have a Year of Space thing happening now. And what they did was they asked a bunch of people to pick a spacecraft that in some way was personally meaningful to them. And they have a lot of really interesting people who are writing these pieces. Michael Mann, climate scientist, James S.A. Corey, the two writers behind The Expanse, Kim Stanley Robinson. There's some really interesting people who have chosen spacecraft to write a letter to. And to be honest, when I first heard about this idea, I was kind of like, don't know how that's going to work out. I have mixed feelings about anthropomorphizing non-human objects, including spacecraft. I think that can get into some pretty dangerous territory. But then I thought that it was actually a really interesting way to show readers that science can have a really kind of intimate personal connection to our lives in ways that are tangible, even if it's not climate change, even if it's not vaccines, even if it's a spacecraft that's literally just telling us that there are billions and billions of Earths in the galaxy. And what does that mean in terms of our understanding of ourselves and our place in the cosmos? And so the letter that I wrote was to the Kepler spacecraft, which spent a lot of years just looking for planets, right? I mean, the impact of that on your average person's everyday life is probably small. But there's a lot to be said for inspiring a sense of wonder and asking people to really think about the very big picture. What is out in the universe? You know, the questions that we can ask now that we know that there are billions and billions of Earth-sized planets are immense. And what would humanity be like without the ability to answer those questions? Well, now we have the ability to do that. So that was one thing. And then just quickly, I think even though in journalism, probably the forum you're most familiar with are, short daily news stories that are covering a thing, as like a study. We do a lot of covering single studies. But every time I write a feature story, we're always borrowing narrative devices from fiction, from people who tell longer stories. And so one of our favorite devices that we use is what I like to call the E story structure, which I guess for the audience would be like this. And it's kind of where you place your reader in the middle of the action, and then you let it go along for a little bit, and then you loop around and tell them how they got there, and then you finish it off. That's the tale of the E. And one really fun story that we did like that is the one I did for the Atlantic, where I was in the middle of nowhere in the Peruvian Amazon, up a valley that nobody had ever inhabited because it's just too far away from anything. And we were camping in the jungle, and I had been told that the animals there were very curious, and they were very not afraid of people. They'd never been hunted. The monkeys would come out of the trees and watch you make dinner, which they did. The caiman in the river would just kind of hang out while you were washing your dishes, which they did. But then the thing that happened was we had a jaguar that just came slowly walking into our camp, and she just spent the night in our camp. And she did not want to leave. There was literally nothing we could do to get her to go. We had no weapons. It was just the situation where we had a very curious cat who laid down. She took a cat nap. Her ears were twitching. She woke up, she looked at us. There were 9 of us, 9 humans with headlamps and like a radio playing the same dumb song over and over again, because what are you going to do in Peru? And in the Amazon where there's nothing. And she just kept she was creeping in closer and closer. And so when we finally got out of there, I'd emailed some biologists and said, like, is this weird? Not exactly expecting this kind of behavior from a jaguar. And they said, no, that's actually exactly what we would expect. And I was thinking, like, that's crazy. And so the story that we did for the Atlantic starts with my friend George shaking my tent and telling me that I had to get out because the jaguar was coming into camp and we had to run for the boat and leave. And then just circling back and saying, this is actually a really interesting example of jaguar behavior that illustrates something that probably nobody's thought about, which is that jaguars are innately not interested in hunting humans, whereas every other cat species in their genus, lions, tigers, and leopards, are. And so where did that difference come from? Is like, how did that evolve? How do we have these cats that are so closely related and yet so very fundamentally different in how they consider humans? That was a long answer. Sorry.
So we've talked about how hard it is to communicate science, even for non-controversial issues. But when we're talking about controversial issues, that makes the problem much harder. So there's some issues for which there's broad consensus within the scientific community. For example, the human impact on climate change, the effectiveness of vaccines. And yet, despite the weight of the evidence, there's a fraction of the population that remains unconvinced. And so I want to talk a little bit about those additional influences that have nothing to do with the science that can affect the communication of the science. So some of these effects are psychological, economic, social, political, media-related. And I wanted to ask Deborah, have you faced these kinds of issues where you had to deal with non-scientific influences that were affecting the acceptance of the results?
Yes, many, many times. I don't usually cover climate change. There's other reporters at the paper that specialize in that, but I do occasionally cover climate change stories. And you know, that's what I hear from a lot of readers when I do that. And I heard from one guy. You know, the story was about NOAA and NASA every year takes like the global temperature of the Earth, and for the past 5 years, it's been the 5 hottest years on record. And so this guy emails me and says, Deborah, have you personally gone to every weather station around the world since 1880? Because if not, I don't know how you can take this data at face value. Aren't you a journalist? Aren't you skeptical? And I was like, okay. Another time I got an email from a guy who said, well, you know, my cousin's a scientist and he doesn't think that greenhouse gases are causing global warming. And I was like, okay, I mean, should I be interviewing my cousins when I'm reporting stories, or should I be interviewing climate scientists? But you know, I think that that's actually really scary because what it really demonstrates is this lack of trust in experts. And I don't know if there's a lot of scientists in this room or some or whatever, but you guys are up against some stuff, you know, because I talk to you, all the time, and the depth of knowledge is so astounding. It's like really smart people I'm talking to, and the idea that someone would equate the opinion of like their cousin or their neighbor, with a scientist who has devoted maybe decades to this study, it's not a good thing. So, I wish I had an answer for how to solve that, but I at least present the problem, which you may have seen too.
There's an issue, though, because journalists are trained to present a balanced view, right? And so sometimes that can result in a misperception of what the actual consensus is. If you present two points of view with equal validity when, in fact, they have very different validity behind them. So here's an example of a chart that compares the scientific consensus on human-induced climate change. 97% of climate scientists agree with this statement. And yet, when you ask the public, what do you think is the fraction of scientists who agree with this statement, the perception in the public, it's like, oh, it's about 50-50, right? So this is sometimes called false balance reporting. Because you pretend to have balance, but in fact you're presenting different points of view that have wildly different validity. So has anybody experienced this in their work?
I mean, I just think it was, I think that for years it was one of the major failures of many journalistic outlets to give too much voice to people that did not believe that climate change was happening. In my opinion, and maybe I shouldn't say this on the record, but I will, it's obviously not a debate. That isn't. You could debate how extreme it's going to be, you can debate the climate modeling, you can debate that sort of stuff, but we know that there is fallout. And I think that was a major, I feel very strongly that it was a major failure. And what you're seeing, and I'm curious how other folks feel about it, what I feel like was a kind of a turning point in the public's opinion about climate change was also the 1.5, the IPCC report that came out last, I think it was October, November, that said we have 12 years or something along those lines. And I feel like that was enough of a holy shit moment for the public that enough people went maybe we should take this a little bit more seriously. And I think that there were some journalistic outlets that started to as well. Everyone has a lot of people have fantastic journalists, but The Guardian, I think, for instance, started printing CO2 concentration along with weather forecasts, I believe. And I think that moves like that, as well as dedicating more journalists to something like that, was obviously important. But for a long time, they wasted a lot of time with
the problem with that IPCC report is based on old information. It's even worse. But I'm not even sure it's the newspaper article that came out about that.
Your microphone.
Hello. I think it has to do more with the weather. They're reporting the weather. Well, the weather's clearly disastrous. The hurricanes are getting more and stronger. The droughts are getting stronger. The fires are getting worse. The mosquitoes, the diseases. Everything is getting worse. The flooding is getting worse. Every year it's getting worse in the South. So it's becoming impossible to ignore. The amount of money we're spending is getting more. California finally got, not finally, but it's going to get worse. I'm the co-chair of the board of the Institute of the Environment here at UCLA, and we have a guy, Alex Hall, who did a report a couple years ago, microclimate model of LA County, and it's going to get much worse. The fires are going to get worse. So at some point, people are going to recognize it. The problem is it's going to be too late. So it's our job as communicators, as scientists, to take that IPCC report, which is actually old news, This last year has been a great acceleration in all kinds of climate problems and get the word out there. But what no one's talking about is there's a reason why the chart is so lopsided. Is I remember when the movie came out, we were screening it in DC for a bunch of people in politics, and the petroleum, there was some petroleum group that was just coming out with it was a terrible ad that CO2 is good for you, and which, you know, we need CO2 clearly for a lot of reasons, and it didn't work, but they figured it out, right? And because they have a lot of money and they put a lot of people to it, and they came back a year or two after we released the movie, and they confused the hell out of people, and it's been a mass campaign of confusion ever since. So we're at war. We're at war trying to win the hearts and minds of people to relay not just the facts and the truth, but to get them to do something about it in a very short amount of time.
But if you just scream, but people shut down when all you do is you give them just, I mean, devastating information all the time. And so I'm curious how, and I don't know, I'm still trying to figure that. How do you talk about this just constant stream of negative, really bad and sad coverage especially about our climate and our world that we cover, like from a Southern California perspective, without burning everyone out? Because at some point, people kind of stop listening. People do have other things going on in their lives.
You're 100% right. And that was one of the criticisms of our movie, in a sense, was because we spent a long time debating how scary, how tough, because we could have made it a lot worse. And then the movie that came out recently, we were like, how scary do we scare? How much do we scare people? How much do we put in there? Oh, that slide's too scary. We're going to pull that one out. We have to scare them enough. And then the solution part, which is the part which gives you hope, how much of that? So you're absolutely right. You can scare people into just shutting down.
I mean, for us with the podcast, we had a really good response. A lot of people sent us, they went out and bought stuff for the first time after living in LA their entire lives. And I think that, and I don't know if you can do this with climate coverage necessarily, as it's such a humongous issue, but with earthquakes, it's like very clear. We gave people tips at the end of each episode. And it's like, this is all you have to do. And I think it's much more complicated with climate change.
The problem is that, I don't want to hog this issue, but there's only one thing we can do now. See, when we made the first movie, there was like a low, medium, and high as to where the curve was going and how bad things are going to be. Unfortunately, we're now way worse than the high. And that's the problem with science in this area. There's no 100%, there's 99%. And so if it's 99% chance it's going to rain, most people here will take out their umbrellas when they leave. So that's a pretty strong number. But at this point, and if that IPCC report, there's changing your light bulbs, drinking, changing your thermostat. Everyone should do that, but that's not going to make a dent. Right now, it's a bigger issue, and governments have to act, and people have to change. The people in the power to make big changes. Back when we made the movie 10, 12 years ago, when it was, everyone could do a little bit, and that would have been enough. But now they have to be big changes. And it's all about changing the people in power to make a difference.
But what does that mean to every person? I mean, and this is important for science communicators. Like, what does that actually mean for me driving down the street or taking my kid to work, or like if I decide to buy, a certain kind of car or something like that? And I guess without people understanding how it's going to impact their daily life like that, or what kind of change that, maybe it will not trickle up to that thing that you're saying needs to happen, which is giant change. But
well, there's the new Green Deal. That's what I'm saying. Even just every person buying an electric car is not going to be enough. At this point, it's such a big problem. So, vote for people who want the new Green Deal, or it's a challenge. You're right, absolutely right. It's a challenge. How's it going to affect me personally? But the only way at this point we're going to get past a point which is going to be not so catastrophic is to get people in power to change what we're doing from a federal level.
So I agree with you, Jacob. It matters how we frame this issue, right? And if people feel threatened that the solution to this problem is going to affect their way of life, that in itself is an obstacle to their accepting the evidence, right? So even if the evidence is very clear, internally they may not want to believe it because, hey, if this is real, then that means I need to do something different, or you know. Yeah, go ahead.
You know, like I said, whenever I write about climate change, I just get this barrage of emails from people telling me I don't know what I'm talking about, or I'm a libtard, or there's all kinds of words that they use. But there's like this small piece of me that's envious that they're not living with this anxiety that we're all living with. You know, they're like,
That's
you know.
so dark. That's so dark.
but they're so sure, you know, this is natural, like, you know, and anyway, it's just something that I think about.
That they're not sitting there with their existential dread every night, like, I have to cover another climate story, and it's really...
So Lawrence alluded to this small group of individuals who were dedicated to essentially shift the perception of the consensus. Right? There's a great book called Merchants of Doubt that talks about this, both in the tobacco industry and the climate change context. I wonder, is there anything we can do, or you can do as journalists, to counteract this ability of a few dedicated individuals to just shift the perception of the consensus?
I don't know if that's our job.
Who else?
I mean, maybe you disagree. I don't know if that's not why I necessarily do that sort of I cover that kind of stuff because, you know, because of the rigorous science behind it, because it's a compelling story. Like, I don't approach it from the perspective of earthquakes were a little different, but I don't approach it from I need to change everybody's minds. Like, that's not necessarily what drives me.
I would agree with that. Like, I personally don't like to feel like I have an agenda when I'm writing. To me, that feels like antithetical to journalism, even if it's like a social justice agenda or, you know, a climate agenda. I don't know that all my colleagues agree with that, though. You know, I think that especially now, the media's role sort of feels more watchdog-ish, I think, than it has in a while. And so I'm the type of journalist that you are, but I'm not sure that, I feel like if one of my colleagues was up here, they might have a different answer.
I feel like, I mean, I don't feel like my job is to persuade readers to reach a certain conclusion, but to present the evidence and teach them through writing the critical thinking skills that would be helpful for evaluating that evidence. And I think my background is as a scientist. I have a PhD in genetics. I never write about genetics. But it offends me to the core when people do not understand that facts and data are there and that alternative facts are really, they're not a thing. Like, that's not a thing. And so part of the decisions that I make in covering various things is like, I'm just not going to give a voice to the people who are on the wrong side of the truth. Like, there is such a thing as truth. And that, I think, comes through in the decisions I make about what to cover. I mean, that could be seen as I have an agenda, but I think it's not so much an agenda in terms of persuasion, but just in presenting things that I feel are scientifically valid. And in so doing, again, as I said, I think one of the things that is missing among large chunks of the population are the skills that you need to evaluate the information that you're getting. And if you don't know how to tell the difference between a fake news story and a real news story, or you have a body of evidence that a whole bunch of scientists who are trained are telling you this is how you interpret that, and then your cousin down the street's like, no way, dude, that's totally not how that works. And you can't weigh those two things and figure out like which is the appropriate conclusion to reach. What I try to do is help our readers at least start to think about, these are the questions you need to ask. Here's this problem. What are the questions you need to answer in order to solve it? What are the data that you need? You have this in your hand. How do you interpret it? Where are the holes? What's missing? What's next? It's basically the scientific process in a nutshell. And yeah, I'm done. God. It's really frustrating. The few climate change stories I've written, I've found the reader backlash to just be enormous. And I was telling Jean-Luc, like, I just don't think I have the perseverance to do that kind of thing because it offends me so personally that, yeah, that we can be looking at the same evidence and reach completely different conclusions. It's like, how does that work?
I mean, I don't know if it keeps you guys up at night, but like every single line that I write, I then lay in bed at the end of the day, and I replay every line, and I'm like, okay, where did I get that from? Where did I get that from? And when we did 9 episodes of a podcast that came out to however many hours, there's a lot of hours spent with like anxiety around every single cited source and everything like that. And I also don't think that the public realizes that, and this isn't every outlet, but especially the outlets that we work for, like, that's the kind of work that's going into, and we're talking to scientists that agree and disagree and all that kind of stuff. So, and I don't think the public understands that.
You know, just to answer, you're asking journalists, but I was on a panel a few years ago, filmmakers, and someone said, they all happen to be movies that have social relevance, and the moderator asked, do you think it's you need to make movies about subject for social relevance? And everyone said yes, except for me. I said no. I happen to make movies, a lot of movies about social relevance, that has social relevance, but not all of them. And so my defense to those others on the panel is like, it's not, people like to do lots of things. I like to just make movies with entertaining. But I also happen to be a person with conscience, and to me, climate change is one of the several issues that I'm passionate about. So I do things in that area, but it doesn't have to be the only thing. Now, climate change is one of those things that's going to affect us all in such a huge way. So I personally feel like it's an obligation of everybody to do something about this, because it's because of those people's cousins who, for some reason, have I'm one of the families that at Thanksgiving will no longer talk to one of my cousins because of the debate I had at the Thanksgiving table. It was horrific. And I will never speak to my cousin again, probably, until my son's bar mitzvah. But it's to me. So, in one hand, it's true. You're right about what you're interested in. On the other hand, with issues that are this big, affecting us in such a short amount of time, I think it's our obligation.
Well, there's certainly power in talking about these issues in movies and maybe TV shows, because you reach millions of people, many, many more than individual scientists can reach. I'd like to shift a little bit to our discussion to the impact of today's media environment. So these days, people get their information from a variety of sources, including tweets and other platforms that didn't exist 20 years ago. So how has this evolving media environment affected your work? Anyone?
Anxiety about employment.
I think what's interesting is that we in television are broadcasters. It's very much seen as a one-way street. But I can tell you for sure that writers and actors and producers do get the reverse flow of information through, whether it's Twitter or whatever else. They talk about what they're hearing about their work. So it is a little more of a dialogue now. Even magazine articles have a comment. Even radio programs have a comments section on the bottom, and so there is more of a dialogue going on.
Were you about to talk? So I gave this question some thought, and I actually came out on that. I think that the current media landscape is helping me do my job, because there's just so much information available. So I write about such a broad swath of science. I couldn't possibly be an expert in all of it. And so, if I'm writing about CRISPR, and every time I write about CRISPR, I pretty much have to go to a YouTube video about CRISPR to just remember how it works and what it is. Sometimes before I interview scientists, I'll find a lecture that they've done, and if I have time, and watch it, and then I just have a deeper understanding of their work before we have a conversation. I feel like you can. So it actually, I feel like, allows me to be the, I'm sure back in the day there were journalists who focused on genetics, and then journalists who focused on space and, you know, health and stuff. And, you know, we kind of do all of it, and I think it's really only possible to be that broad and not wrong because of how easy it is to find people. I will say, and I'm curious, what I think the challenge is that we're all barraged with so much information all the time, and I personally, I feel conflicted about being part of like what I call is the attention economy, you know, so, or not me, but you know, I want you to read my stories. I want you to think like I have to click on that headline, like what, you know, what could that possibly be about? But I also want people to step away from their computers and like be in the world. And you know, so I don't know. I was thinking about what you were saying about rising above that din, and you want to rise above the din, but if everybody rose above the din, I mean, it would just be so dinny. So anyway, that's something that I'm, you know, still kind of thinking about.
All right. So you know, we can't leave today's event without addressing how we can improve science communication. I'm going to ask a few more questions, but then I want to give a chance to the audience to ask questions as well. There should be index cards that have been distributed. If you have a question, or volunteers can pick them up, and we'll try to go through some of these. So if we could summarize, what are the biggest challenges that you experience when you're trying to communicate science effectively to the public?
I mean, I think one of them is finding the right story to tell about a particular issue. And climate change is such a great example, because to reach the audiences that we need to reach, we need to tell them a story that's going to engage them. And finding the right story for the right audience is not easy. I was on a panel not that long ago with another science journalist, and she was saying that, and I don't think I agree with her, but she was saying that polar bears are not the story to tell about climate change because nobody cares about polar bears. And my bias is I really care about polar bears, and I want them to be okay. But I think she might have a point in that you're not going to win over, you know, the people in coastal Florida by telling them that the polar bears are going to die. So I think one of the challenges is finding the right story, and you know, at the risk of repeating what was said on Game of Thrones the other night, like stories are really important, and I think that's one of the primary ways in which we can get a point across, sometimes without readers actually or viewers realizing that we've done that. So finding those stories, I think, is a key challenge, and unfortunately, a lot of publications don't have the resources anymore to do that, is my opinion.
I would just add that the other half of that is you can tell a good story, but if you have someone with an agenda who has a lot of money telling another story, it's not just climate change, there's many areas that the facts get confused by some industry that happens to have a big stake in having some other kind of information put out, right? Obviously, the tobacco industry was clear doctors saying that smoking is good for you. And it continues today. So I think you need to tell a good story, but then it's very hard to go against large groups that have an agenda that are the opposite of what the facts are. There's nothing you can do about it, really, at this point.
I think that, I do think that there has been some,
Sorry to be depressing.
if we're talking about like the both sidesism around climate change stuff too, like I do think that some outlets that have dedicated now, like New York Times very clearly has like whatever, illustrators and video folks and a whole suite of, I mean, they have a lot of money, and just a whole suite of people specifically dedicated to climate change. And so while they're not activists and that's not why they're doing that coverage, I do think that those additional resources being funneled to that through news organizations does boost, you know, hopefully audience literacy in the topic, and maybe steers them towards the truth about a lot of this stuff. I mean, that's the hope, I guess.
Yeah.
So that's kind of hopeful.
Any recommendations on how either scientists or journalists can improve science communication?
Please, are there any scientists out in the audience? Oh my gosh, there are. There are so many scientists here.
Thank you for your work.
I hope that we get to talk at some point. I want to hear your personal stories. I want to hear the stories behind the studies. I need those narratives. Please share them with me. And please, please, please understand that my audience, and it might be different than LA Times or Nat Geo or The Atlantic, but at least for NPR and KPCC, we need to keep it basically jargon-free. And I will talk to you with all the jargon in the world, and we'll have fun with that. But at the end of the day, when I pull that 15-second clip that needs to explain the entirety of like 5 years of your research, I'm so sorry, but that's what I have to do. Please be patient. We'll walk through it a couple times, and thank you. I'm so glad I got to plead with the scientist. Thank you.
One of the things that we run into a lot, or at least I do, with stories is when I'm reporting something, I'm never really just going to include the voice of the person who did the work. I think it's important to give readers broader context, and so what I normally do is I'll go ask somebody else who works in the same area for a comment on the finding or whatever it is, just to give me an outside perspective. And often people are really kind of timid about being critical of work in their field, and I think that actually does a disservice to science in general. And so I would say to scientists, like, don't be so afraid to be critical. I understand that there are political reasons behind like not necessarily knocking someone's work, but it's also important, for us, we need to know if we're covering bad science. That's important.
Really?
And if there's something that's really flashy that's getting a lot of attention in the press and it's not covered very well, you don't have that person coming in and saying, yeah, but hang on. You're giving readers the wrong impression about what the science is telling them. And I think that's been a big problem. I mean, vaccines, hello.
Yeah.
Like the anti-vax movement rose because there weren't, false balance and people weren't really covering that well. So,
David, what's your take on this? How can we improve either as scientists or do you have any advice for
serious nonfiction going on here? I'm from a fictional outlet where the hardest hitting blow for science we made was against astrology. So we went way out on a limb. I mean, maybe there's something interesting to say, and I don't know if it has any impact on the journalists. I have kind of the opposite experience of the Al Gore movie, which started with the science, and if I understand, and you made it interesting. Is that a fair assessment?
I hope so.
And my experience with the fiction writers, well, it's let me maybe tell a little. Do you have a second? Tell a little story.
Yeah, sure.
One of the boys is a physicist on the show is on a date, and he takes an olive and spins it in the glass, and it stays in the glass without falling out. And the girl he's dating says, "Wow, centrifugal force." Some people laugh. And he says, "Actually, it's centripetal force. It's an inward force generated by the glass on the olive, etc." So people in this audience, if I asked them, what was that scene about? They would probably, I think because so many scientists were here, say, well, that was a scene about the difference between centrifugal and centripetal force. Believe it or not, if most people you asked what that scene was about, they would say it's about a boy trying to impress a girl on a date.
That's
100%.
So I don't know if this experience helps you or not, but I can just tell you that my experience with the fiction writers was they always started with the story, the human story, and the science came along to make it real. Now maybe it's just like aspirin in the applesauce, I don't know.
Yeah.
But I don't know, does that have any bearing on your work, real work in nonfiction?
In my work?
Or
So-
anyone here? Or,
Yeah, it doesn't help when scientists are super myopic about what we're necessarily talking about, because we do have to relate it to a general audience. I don't know how you guys feel.
It's going to help me on a date.
Yeah.
100%.
Well, I'll just say that I think a lot of scientists do a great job communicating their work, and I had some stereotypes in my head when I started this beat, and that maybe, you know, people were going to be so deep in their kind of rut, or you know, it's a deep dive. They wouldn't know how to kind of communicate to people who aren't like down there with them. And in general, I found that scientists have been, you know, they totally get what's cool about their work. They're happy to answer the most basic questions. I think I asked an astrophysicist at Caltech before the image of the black hole. I just said, I'm so sorry, but like, what is a black hole? You know, and she didn't flinch, you know, she just went right there with me because I just wanted to like know it. So, you know, thank you for your work, and thanks to every, you know, I don't know if I've talked to anybody in here or not, but I'm always so grateful for, you know, your time and expertise.
So I'd like to follow up on about what he wants to hear from scientists. And there's another clip from Sarah McBride, and it's a short clip. Let's have a listen.
People go, oh, I relate to that guy. That guy, you know, he speaks the same way I speak. He's relatable. He tells it in a story. I understand his life. And he's not someone who seems so removed emotionally from me. He's someone who shows emotion, who shows concern, who expresses why. And that's something that's often drilled out of scientists. You know, we're supposed to remove passion from our work because we don't want bias to be in our work, and we're supposed to remove personality from our work, and the work is meant to speak for itself rather than the work being an extension of who we are and part of our story.
So I think that's a real challenge for scientists. I mean, you want to hear the human side of it, and wouldn't you agree, David, that for us, we want to talk about the work and try to remove ourselves as much as possible from it?
I can also say something that's kind of interesting about a scientist's perspective of dealing with journalists.
I'm sorry for whatever it is already.
When we write papers, we agonize over every sentence and every word for months. I think that's fair, if not longer. And it's really kind of alien for us to speak to someone else who's then going to speak for us. It's actually, if you want to hear our side of what's going on, that's very difficult for us.
I have scientists offer to proofread my
all
my work, and I always thank them, and I say I will call you for a fact check. But I was also, you know, on the flip side, like I was interviewed the other day for I think The Indicator, the Planet Money podcast, and it is like terrible being interviewed, and that's something that I think that we at least I as a reporter forget sometimes. I understand like it can be very vulnerable, and that at the end of the day, like I always say congratulations to the people that I talk to, especially about their papers, because I know it was just it could have been years of their lives that kind of went towards that thing. So I think that it's important for us to be sensitive about that, but I do want to hear your personal stories. Like they're important to me.
That's why TED Talks work so well.
Yeah,
because they really have. I mean, they may not go as deep as a scientist may want to go, but they really refine the talk for media, and so you always have a personal story as part of the talk, and then you get as deep as one can go. And as a scientist, you might already understand that, but you know these have hundreds of millions of views. And so many people watch TED Talks about everything now that would never have watched a talk before about a scientific issue. So I think the emotional aspect of it and a personal story, I think, is really important.
Yeah, thank you. So we have some great questions. One concept you think most movies get wrong despite how hard they try?
I feel like that's you.
Yeah,
I can tell you one thing I don't know how to solve, and is that on most lab equipment, you can't see the laser beam. And I don't know a way around it. But when you see the laser blast going pew, pew, and you see them moving, that's pretty wrong.
Okay. That's a good one.
I suppose there's the perennial sound in space.
That doesn't bother me so much.
Okay.
Because there is about one atom of hydrogen per cubic meter
Yes.
in intergalactic space. And I know the density, I don't know what the bulk modulus is, but there's probably a speed of sound. And we should talk later.
Let's do the math later. Another great question. Any advice for a geology major looking to getting into science communication? Nadia, maybe you have something to say.
So yeah, come talk to me. It's probably easier. There are a lot of ways to get into science communication. It depends on what exactly it is you want to do in that field. I don't know who I'm talking to. But depending on where you want to go, the routes are different. I will say that I ended up doing a year-long science communication graduate program at UC Santa Cruz. So I went to graduate school twice, which was fun. But I needed to do that because I had gotten so used to writing in a scientific way and I knew nothing about writing for a popular audience. And unlearning everything that I'd done in my PhD program was a little bit painful, and it took a while. But that was what I needed to do. And there are a number of those graduate programs around the country. However, many, 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 many science communicators do not go to a graduate school program at all. And they just kind of, you can come in laterally and end up doing a magnificent job. And so, yeah.
I'll just add, we get an intern every year from AAIS. They have like a science communication program for PhD students, I think, or recent grads. And so that would definitely be something to look into. And whoever this geologist is, I love the idea that like rocks have stories to tell if like only you know how to hear them or read them. And so I long to hear your whatever you want to communicate to us.
Great.
You should look at what Lucy Jones has done too. Okay. Who's this geologist? Can you raise your hand? Yeah, so you should look at what Lucy. She's a seismologist. She was like the queen, the queen of quakes, kind of before she retired from USGS, and her career has been really interesting because she actually left doing like peer-reviewed research to specifically go into advocating for preparation for earthquakes and such. And she's just a very good communicator. And she has her own institute. I'm sure you could actually email her and ask her some questions too. She's really, really great.
Another question. Scientists can seem earnest, dramatically dull. What is one compelling or intriguing thing you have discovered about scientists that you wish more people knew?
You're not dull.
Yeah, I know.
You're not dull.
Yeah.
Feel good about yourself. You have really what you know. Most people do not know.
I also feel like scientists need to sometimes stop talking to each other because I mean, well, just
no
because
more
That'd be great.
At my synagogue, there was a guy who was like an engineer at JPL, and I said to I was there with my kid who's 8 years old, and I don't know what this guy does, and I go, oh, Zev, Brian works at JPL, and Zev fell down on the ground. I mean, that's how psyched he was, and so I just think that sometimes. I think some scientists are really into what they're doing, and some often grad students stop remembering what it was that they loved about the work. But you should talk to like any of us because we'll be like, that's so cool, tell me everything. So I just, we don't think it's dull.
We will have an hour-long conversation. I will ask you about your childhood, and I legitimately want to know about it, please, and how it influenced your look into whatever. I'm serious.
All right, and here's a more serious question. I know you may not consider it your job, but do any of you have an example of your work overcoming someone's motivated reasoning? This is one of the biases we talked about accepting new evidence. And if so, how did you do it?
I have a, it's not the greatest story, but I felt like it got me somewhere. I had an email. I don't know why this guy emailed me, but he was a climate change denier, and he said, he sort of he must have attacked me, but not in curse words, so I responded, with questions about how this research could possibly be real or something. And I responded, and he was delighted that I responded. And he said, I know everyone thinks I'm so stupid because I believe in climate change, but I'm not stupid. And I was thinking, the fact that you don't believe in climate change made me think that you hate me because I'm a journalist. And I had just gotten some really weird racist email from someone that somehow equated something about Muslims. It made no sense, but I just wanted him to understand when I get these sort of angry emails, like what they're often paired with, and I said that to him, I just got this weird racist email about Muslims from someone who was talking about climate change, and he was like, that's awful, it's really awful. And I just felt like for a minute we were just two human beings, not in agreement, but not like this, and that happens so rarely, and I don't think I changed his mind. He certainly didn't change my mind, but just for a minute, I was like, oh, this guy doesn't hate me, and I don't hate him. So that's the big win.
I have to give you one example. I just remember I was on a plane coming back from someplace, and I was with an older gentleman from the Deep South was sitting next to me, and there was nothing about the two of us that was similar. Right? We were very, very different people. And he was like, and we started talking. Well, what, so I asked him about those, I'm not going to do the accent, but Southern accent, asking me about why would we want to give immigrants or people who are not documented driver's licenses. That's like crazy. And I asked him, well, why does he think that? And he explained. I said, well, let me ask you this. If you're driving down the road and a guy smashes into you that doesn't have a driver's license, not insured, is that worse, or is it worse having a guy driving down the road who had to learn how to drive and then get a driver's license, and so we actually started, that makes sense. But it was odd because I started off going, oh man, it's gonna be a long trip. Wow, this is really interesting because he definitely had a really set of prejudices. But when we actually started talking about the practical application of the things he was talking about, it seemed like, oh, you got a point. And it wasn't about climate change, but it was one of my more interesting conversations I feel like I've ever had. About two very different people kind of coming to terms on different, and I started to understand what he was thinking,
Well, thank you for sharing. So it sounds like our panelists would welcome some interactions with the audience. So I suggest we wrap it up. Thank you so much for spending this evening with us and for this discussion. And thanks to all of you to come and participate in this special event. If you want to learn more about our events, go to our website, epss.ucla.edu. Thank you and good night.